In the previous video, we looked at allocating using the Hungarian algorithm process where the number of lines equals the number of rows in the matrix the first time. In this case, we're looking at allocating using a Hungarian algorithm where the number of lines does not equal the rows of the matrix the first time. So to illustrate this, we've still got our steps shown here. As I said before, you obviously won't get these steps printed out in an exam. It's just for our working, and this needs to become internalized. So let's look at the context of the question. We have 4 workers, A, B, C, and D, all provided quotes for jobs 1, 2, 3, and 4. Their quotes in thousands of dollars are shown below. Determine the best allocation of workers that minimizes the total quote and find the total cost of this quote. So yet again, we're minimizing. That means we don't need to invert the matrix at the start. So we need to allocate. First thing first, let's just make sure there's no dummy rows or columns required. A dummy row or column occurs when you don't have an equal number of rows and columns. We've got 1, 2, 3, 4 rows and 1, 2, 3, 4 columns. Therefore, there's no dummy row, and we can go on to the Hungarian algorithm process. Step 1 says subtract the smallest entry in each row from all entries in that row. So let's do that now. We've got our minimum there is going to be 15. Our minimum here will be 18. Our minimum in that row is 13 and 10. We draw out our matrix, in this case it's a 4 by 4. We subtract away the minimums from each row. So now we've completed step 1, which I've already ticked. Step 2, subtract smallest entries in each column. So we can see here that 1 and 2 are our only ones we have to deduct away from, and then we'll continue. So these stay the same. Oops. Let's subtract 1 away. Okay, so now we've completed step 1 and step 2. Step 3, one of my favourite bits, is draw straight lines through the rows and columns so that all 0 entries are covered. So off we go. Now we need to cover them with one line the most zeros first. So if I cover this one, we've only covered 1 0. This row I cover 1, 2, 3 zeros. There's nothing better than that. So I draw my line across there, and this is where it's helpful to have a highlighter. Now we've covered that there. We look at the remaining zeros. I've got 1, 2 zeros there, so I cover that one. And what's left, I've got this here. I can either draw straight or I can draw across. Okay, I'm going to draw across. Now, what we've done here is we've covered the number of lines, all the zeros, okay? And we're going to investigate, does the number of lines equal the number of rows? Well, we can see the number of lines we drew was 3, and the number of rows we drew was 4, therefore they're not equal. So let's have a look at step 4, and let's see what it says. If the minimum number of covering lines is equal to the number of rows in the cost matrix, go to step 6. Now this doesn't apply now, unfortunately. So we're going to, we're going to have to go instead to step 5. Step 5 says this: find the smallest entry in the matrix not covered by any line. That's our 1, and I'm going to circle that. So our minimum is 1. Subtract this entry from all uncovered entries and add the 1 to all entries covered by a line twice. So this is the intersection. So intersections here and here. So I like to do the intersection first. So I'm going to plus 1 there. So I'm adding that to the intersections, and I'm subtracting 1 from the rest. Remember, it's just the uncovereds that get subtracted 1 from. So what's our next step? Well, we make a new cost matrix. I'm just going to scroll down, and we're going to continue this process. So draw it out. And going down, we can see 0 stays the same, and then 7, 16, 0. Our next column, 8, 0, 0, 7. Our next column, 23, 0, 16, 5. And just a reminder, I didn't write in the take 1 there, but we do indeed subtract 1 from 1 to make it 0. So if the number of covering lines is less than the number of rows, so we've done that, we're on to step 5, find the smallest entry in the matrix. We've done that now. Subtract this, we've done that, and now it says return to step 3. Okay, so let's return to step 3, and we're drawing the straight lines so that all 0 entries are covered. So we're just repeating this process until we find the number of lines equals the number of rows. So let's cover our lines. We can see this yet again has 3 zeros through it. So let's highlight that. And where's our next one? This one's 2, this one's 2. So I'm going to highlight that one. And now we can see here, I can either go across or up, and here across or up. And then there. So does the number of lines equal the number of rows? Well, let's look. Number of lines we just drew is 4 equals 4. Therefore, tick. We can say that the number of lines does equal the number of rows. So we went back to step 3, and it says if the minimum number of covering lines is equal to the number of rows, go to step 6. So now we can go to step 6 now. So circle and select and circle a 0 entry in each column. So it's time to allocate. We can see task 1 here. Task 1 would have to go to A. Our next one, well, now that A has been used up, we can see that A can't also be allocated to task 4, and task 4 has only 2 people who are optimally allocated. So because task 4 can't use A anymore, they'll have to use worker D. And let's have a look what's left. Well, we have this one, only person B can do task 3 effectively, so circle that. And we have that one remaining. Now we go up to the top and we just circle those same zeros. So we've got task 1A. Okay, now we just write out the allocation. So I write out 1, 2, 3, 4 for the workers, arrows to show the allocations, and then I go task 1 is going to worker A, task 2 is going to worker C, task 3 is going to worker B, and task 4 is going to worker D. Now we write out those times, so that is going to be, oh sorry, it's thousands of dollars, isn't it? This is 15, we're just going to say dollars for the time being. Task 2 is 19. Task 3, 13. And task 4 is also 13. Now we need to add these up. So 15, 34, 47, 60. And let's just go back to the context of the question. We get 60 what? Well, it said their quotes were in thousands of dollars. So we just add another 3 zeros to it. And so this is the total. The total quotes were $60,000 to minimize the total quote for this job. And that is our video there for using Hungarian algorithm when we're minimizing when the number of lines does not equal the number of rows in the matrix the first time.